Welcome to another video. Now, logarithms and the next video, which will be of trigonometry, is so very important that if you do not know your logarithms, I bet you won't be able to pass your test. I repeat, you won't even be able to pass your test. Other topics such as, concavity or intercepts or even the binomial theorem, if you don't know them, you lose a few points, a few marks. But if you don't know your logarithms and your trigonometry, you're not even going to pass. You won't even get a score of 3. You'll probably be stuck on a 2 or a 1. That is the magnitude of this guy right here. So I want you to pay attention and learn whatever I ask you to. Let us dive straight in. I'll begin with the definition of logarithms. And while there is a common misconception that logarithms is a very tough topic, it is actually a very simple and easy topic, easy to grasp as well. Now, the definition says that given that A and C are constants and a number B such that B is greater than 0, which means B cannot be negative and B should not be equal to 1, and then if B to the power A is equal to C, then we have log base B of C is equal to A. Now, I'll explain you what a log essentially does. There's one number in the base, which is written at the bottom in the indice, which we refer to as the base number, and then we have a constant on the top, which is the C in this case. So what a log function tells you is that it asks you the question, to what power do you want to raise the number B to get C? I hope you're getting me right here. To what number do you raise the power B to get C? For instance, if I tell you log base 2 of 8, what did you write in this case? Well, the answer would be 3 because I raised 2, which is our base number, to the power 3 to get 8. If I asked you what is log base 5 of 25, your answer would be 2 because I have to raise 5 to the power 2 to get the answer 25. If I ask you log base 4 of 64, what would your answer be? Your answer would be 3 because I have to raise 4 to the power 3 to get 64. That is what a log function is all about. To what power do you raise your base number to get the number which is written above? That is a very simple thing. And when you write it as a general form, if I write log base b of c, and if the answer is a, it means I raise b to the power a to get c, which is I write b to the power a to get c. And these are interchangeable statements. I can write this and I can even write that. That is the very simple definition of a logarithm, and I hope this should be crystal clear. What you have right here are a few rules that govern logarithms in particular, and in this video, I'll not be going through the detailed proof of why do numbers add up, why do numbers divide here, why do numbers get subtracted here and stuff like that. I'll rather go through each rule very quickly, like a recap, and I'll show you the various uses. So we'll begin one by one, starting with the product law, then the quotient, then the power law, and the very important change of base. I have with me right here the product law, which states that if I have log base b of x times y, it can be equivalently written as log base b of x plus log base b of y. I'll give an example right here, but before I give you the example, I want you to take note of one very important thing. In many logarithms, you'll notice that the base number is absent. They'll directly write log 57 or log 68 or maybe a log 100, anything like that. The base number will be absent. You won't find any base number. And it is by convention that when you do not find any base number in a logarithm, it is assumed to be 10. The base here is 10, the base here is 10, the base here is 10. It is by convention that whenever you do not see a base written and just a log 57, the base is assumed to be 10 because a base 10 is the most common logarithm, and that is the most useful one when you study higher math. So log base 10 of 100 or log 100 would just be 2. And to compute these guys, you'll need to have a calculator. So I wanted you to take care of one thing before we move ahead. Just a moment. I hate it when I have to do this. Yeah, we're back. Now I'll start with an example. If I write log 8 or just any composite number, then remember that you can always split it into log 4 times 2. And by the product law that we have log base b of x times y, we have log 4 plus log 2. Log 8 can be written as log 4 plus log 2. If I had log 100a, I could write this down as log 100 plus log a. But I know log 100 is 10 to the power 2, so log 100 would be 2, and log a would be log a. So log 100a can be written as 2 plus log a. That was about the product law. Now, quite similar to the product law, we have the quotient law, where it states that if you have log base b of x by y, you can write it as log base b of x minus log base b of y. So the only difference between the product law and the quotient law is that the product law relates a multiplication and an addition, and the quotient law relates a division and a subtraction. And I'll give an example. If I have log c by 10, and again I'm not writing the base, so it is assumed to be 10, then I can write this as log c minus log 10, but log 10 is 1. So this is log c minus 1. So this is log c minus 1. Let me give you another example. If we have log ab upon 10, I can first write this as log ab minus log 10, but log 10 is 1, so I have log ab minus 1. But again, if you keep in mind the product law, you have log a plus log b minus 1. This is how you can simplify log ab by 10. Let's move on to the next law. Now the power law is again a very important law. It says that if you have log base b of x to the power n, then the n which is in the exponent can be shifted ahead to get n times log base b of x. For instance, if I have log 49, then I can write this as log 7 squared and understand that we have the base 10 right here. So the 2 will go ahead. I have 2 times log 7. If I ask you log root x, let's take root x, then this can be written as log x to the power 1 by 2, which is 1 by 2 times log x. That was quite simple. Let's move on to the last rule. Now the last and maybe the toughest one is that if you have log base b of x, it can be written as log base a of x upon log base a of b, where a can be any number, but a should be greater than 0 and it should not be equal to 1. So which means that if I have any logarithm, any base, any number, log base b of x, I can take any base a and get log base a of x upon log base a of b. I'll show an example. If I have log base x of 10, I can write this as log, again, the number which is on the top goes to the top, and the number which is in the base goes in the denominator. So this would be log 10 upon log x. Now what should I choose my base to get a more simplified version? I could take log base 2, I could take log base x, I could take log base 20, but the most efficient one over here would be taking log base 10. Since we're allowed to choose any base, this means that log base 10 of 10 just evaluates to 1 and you get a log x at the bottom right here. So this guy right here, log base x of 10, is just 1 over log x. I'll give you one more example. I'll have to erase some part. You can skip this part. Yeah. So the next example would be, let's say log base 9. What happened to my 9? Write it again. Log base 9 of 5. Now again, the top number goes to the top, so I have log 5. We'll look at the base later. Log 5 upon log 9. Now I could either take a base 9 or take a base 5 because you want at least one of either the numerator or denominator to be 1 or a whole number, right? If I choose 9, then I'd have log base 9 5 upon 1, which is what we already had. And if I take log base 5, I would have 1 upon log base 5 of 9, which doesn't help me much. But if I took 3, then I would have log base 3 of 5 upon 2. Alright, this gives you something you can work with. And again, if you take log base 9, there is nothing wrong with that. If you take log base 5, there is again nothing wrong with that. It depends on the question and it depends on your needs in the particular question. So there is nothing wrong, but just remember that a should be greater than 0 and a should not equal to 1. Let's move ahead. Now, before we move on to practicing questions, there is one topic that I'd like to cover, which is of natural logarithms. We have that the natural logarithmic function, denoted as ln of x, is a log function whose base is the irrational number e, called the Euler's constant. Now, the formal definition of e comes from a calculus course using limits and derivatives, and right now you don't need to understand that. You just need to know that whenever you have a logarithm with the base e, then it is conventionally written as ln of x, where ln itself means log of e. Okay, whenever you write ln, it means that you have a logarithm with the base e. So when I say ln of e, it means that ln of e, the base is already e of e, which will evaluate to 1, which is what I've written right here. So remember one thing, whenever you have an ln, it is just a logarithm with the base e. Let's now move on to some practice questions. Now, we have a question right here that says solve for x, which means you have to find the numerical values of x that will work for this equation. Now, your AP pre-calculus test will be centered around the steps or the methods that you go through here, so pay attention to this. Now you'll notice that you have the same base over here, log base 3 and log base 3 and log base 3. What I'll first do is I'll simplify the LHS first, which is the left hand side. And according to the product law, if we have the same base, then you can multiply them. So I'll have log base 3 of 80x is equal to 2 plus log base 3 of x squared minus 1. Now, whenever you're working with logarithms, make sure to have the constant terms on one end or on one side of the equal to and the logarithms on the other side. That way you can bring it into exponentiation. So I'll shift my log base 3x squared minus 1 to the left hand side. So I'll have log base 3 of 80x minus log base 3 of x squared minus 1, which will be equal to 2. Now, according to the quotient rule, I know that I can divide. If I have the same base, I can divide 80x by x squared minus 1. So I'll have log base 3 of 80x upon x squared minus 1, which will be equal to 2. Now, remember when we started the video first, I explained you if we have log base b of c, which is equal to a, then it means b to the power a is equal to c. This actually comes from the definition of a logarithm. So if I apply the same thing right here, I have the base 3, I have the exponent 2, so I raise 3 to the power 2 to get 80x by x squared. So next step from here would be 3 to the power 2, which will be 9, is equal to 80x by x squared minus 1. Let's move to the next slide. Now I'll move the x squared minus 1, which we have right here, to the other end. So I'll have 9 x squared minus 9, which is equal to 80x. Now all of us know how to solve a quadratic equation. This will be 9x squared minus 9 minus 80x, which will be equal to 0. And if I quickly calculate, how could I? Yeah, I'll have 9x plus 1 times x minus 9, which will be equal to 0, which gives me x could be either negative 1 over 9 or it could be 9. Now, understand that exponents can never be negative. So if I have a negative number in my constant, it will be undefined for all logarithms, right? I cannot have any number log base b of c to be a where c is negative. I cannot have a negative c. So you immediately discard negative 1 by 9 as an option because it is a negative number and the domain of logarithmic functions is only positive real numbers. So the only solution right here that you have will be x equal to 9. I'll move on to one more question using natural logarithms. Now the next question here tells us to find for the values of k, and if you notice carefully, you have the number e, you have the constant e right here, and that should immediately strike you that you will have to use a natural log instead of a regular log. So before we begin this question, remember I told you about how you're supposed to bring the constants on one end of the equation and the exponents or anything else on the other end. So in this case, I have 17 is equal to 20 times e to the power 2k, and I have a constant 20 with e. I'll move that to the other end. I'll have 17 by 20, which is equal to e to the power 2k. Now I want to bring 2k from the exponent to the base so I can work with it. And for that purpose, we'll use a natural log on both ends. So we have a natural log of 17 upon 20, which is equal to the natural log of e to the power 2k. Now the natural log of 17 by 20 is something which we cannot do anything with. It has to remain as it is. But on the right hand side, you'll realize using the power rule that if we have log base b of c to the power a, we can move the power a in front. So instead of a ln of e to the power 2k, I have 2k times ln of e. Now remember, ln of e will be 1 because a natural log is a logarithm with a base e. So I'll have natural log of 17 by 20, which is equal to 2k, and ln of e is 1. I'll move to the 2 to the other end. I'll have natural logarithm of 17 over 20 upon 2, which will be equal to k. Now on the test, if the graphing calculator is allowed, then you're supposed to put in the value of 17 by 20 into the natural logarithmic function and then divide by 2 to get the value of k. But if the graphing calculator is not allowed, then this answer that you have right here is totally allowed. And I think that'll be it for the logarithmic video. If there's any doubt, feel free to ask in the comment section below. We'll meet soon. Thank you. Have a good day.